This training will mostly be about the microprofile, and Quarkus is just an implementation that we're going to use. There are some Quarkus specific things in there, but mostly what you're about to learn will apply also to other microprofile implementations, but we'll get into that later on. My name is Jago Vreede. I'm here from the Netherlands, and I've been working with Quarkus quite some time. Actually, before the first 1.0 release, I was playing around with it. I believe it was somewhere in mid-2019. So I've seen almost every version, skipped a few, of course. And I've been working with Quarkus in my professional job for about 2 years now. So that really gave me an eye-opener what Quarkus can do well, in the enterprise world, to be exact. So what is this training all about? Let's first share the agenda for today and tomorrow, and you have a broad idea what this training is all about. First, it's an introduction and expectations from you guys. So at this point, I'll be sending a lot of information to you, but I hope that this will become a interactive session. Then we're going to discuss the case that we're going to build on in the couple of days, starting in Hello World with Quarkus, and that's even before we're knowing what Quarkus actually is. And then we're going to start learning about cloud native, microprofile, the data model that we're going to use. Well, we're going to build a REST API. There's time for some lunch at 12 o'clock. Then we're going to use Liquibase or Flyway to create a database schema or any other database script that we want to use. Then with that database in place, we're going to use JPA and Panache, and also some unit testing with Panache. We'll get into what Panache is later on. And of course, the MicroStream implementation will also be discussed, hopefully by Rudy. And then we're going to wrap up, and that will be the end of day one. The second day, just to recap where we were, we're going to build a shop service, do some configuration. And in the afternoon tomorrow, we'll be doing health and metrics, configuration, fault tolerance, and if we have time, we're going to try and build a native image from our application. And if people are flying through the course, then there will be time for some tracing. So first off, some introduction and expectations. I would like to know who you all are. I'm seeing black screens now with some names in it, so that's not really informative for me. So who are you? Where are you from? What's your experience with Java? And do you have some EE experience already? And maybe if you have used Quarkus before. And I would like to know what you would be expecting from this training. So I maybe can be able to tailor this training a little bit for you. So if I kick off, then, well, I've said before, I'm here from the Netherlands. And I've been using Java for about, well, let's say 15 years or so. And mostly of the time that was in the EE world, in the Java enterprise applications with WebSphere, WebLogic, JBoss, and that kind of stuff. There were some string applications in between that, but mostly there were the Java enterprise applications. And like I said, I've been working with Quarkus since almost the beginning. And I expect that you guys will be having fun with this training. So I'll be doing a round. It would be nice if you could unmute and maybe show yourself as well in the camera if that's possible. So without any order in mind, the next person that I have on my screen is Rahul. Maybe you can introduce yourself. If that's not going to work, maybe Repco.
Goedemorgen, Jago. This is Repco from Netherlands. I'm near The Hague. I have no experience in Java, just trying to learn it myself. And Quarkus is one of the things that I like to do because of the deploying of my application that I want to build. And it seems quite easy to do the deploying on Quarkus. So that's why I want to learn.
Yeah, cool. Maybe Till?
I'm sorry, I just got some problems. Hi, I'm Till from Germany. I've been using Java for around 5 years, of which I think like 3 years I've been working with Java Enterprise Edition. I don't have any Quarkus experience to this day, and I'm looking forward to learn something new about Quarkus and MicroProfile, especially in this training.
All right, thanks. I see that Thomas has shown his webcam, so maybe we'll go next.
Hello, my name is Thomas. I'm searching and looking for new things, and Quarkus is a new thing for me. I'm always experienced with MicroStream, and so it's good that you put it on your list. And I will join the 2 days and looking forward to get some actions for me to prove what I'm looking for.
Okay, thank you. I'm probably gonna butcher some names now. Venkata?
Hi, Jago. So basically, I'm a newcomer in Spring ecosystem. So I would like to know more about MicroProfile, Quarkus, and get more experience out of it from this training workshop. Thank you.
All right, thank you. Then it's UV Hoffa. Hello.
Sorry, my name is Uta from Ufa. I will change my name then as a new login. I'm from Germany and from IBM. I'm using Java for about at least 10 years. I have experience in EE, but I have no experience with Quarkus, and I want to learn more about this framework. And this is what I expect from this training.
All right, thank you. Marcus?
Yeah, Marcus is the boss of MicroStream, so I guess he just joins to see how it is going. So
how it's going, okay.
He might be interested in Quarkus, but
cool. And then Jörg.
Yeah, hello, my name is Jörg. I'm from Germany too, as Uta. I've Java experience in 15 years, but I'm not coding every day. My role is test architect and Scrum Master. But I just want to stay up to date and want to learn what Quarkus is about and how you test it later on.
Right. Then maybe Rahul has.
Yeah, hi. So this is Rahul. So I'm basically from India. So it's been a nine around experience total in Java. So I worked in Spring Boot and microservices only, but I just want to have to learn the implementation from scratch. So whatever the chance I got, is it the already built application where I do the coding and stuff, but from I need to learn, I wanted to learn from scratch something. And also I'm looking for some different kind of approaches to learn from. So I thought to register for this course to learn the new things and do some things from scratch.
All right. So there is some mix in here. Some people
Yes.
are quite new, some people are quite experienced. So probably the speed of which you guys go through the exercises will differ a bit. So maybe for some of you, exercises will be quite easy and you will finish quite soon. For the others, maybe you need some help with us to go along, but we'll see how it goes, and I'll be here for questions. Maybe we can create breakout rooms and go in there if there are in-depth questions or specific questions that you guys need. So with that in mind, what we're going to do in a couple of days is to build a bike store. It's a traditional application. It's not your pet shop. This time it's the bike store, and it was created from the SQL Server sample database. It has at least a product and a cart in there, and a consumer and the kind of stuff. There's all kinds of information in the sample database. I've extracted the good stuff from it, and I'll snip away the plumbing and the stuff that was interesting for SQL Server, and just kept it as a simple bike shop. And there will be 2 microservices in there. So we're going to create a inventory service, and we're going to create a shop service. So there will be some interactions between those 2 applications. So we have a little bit of feeling on how to develop microservices. And if there are any questions in the meantime, just ask them. Like I said, I would like to have an interactive session, but we'll see how that goes with online stuff. But first, we're gonna need to do some things. Before we get started with anything, learn about Quarkus and that kind of stuff, we're just gonna need to do a few prerequisites and create a Hello World application with Quarkus. There is no need to have any information about Quarkus yet, except that it exists. And in this website that I'm going to share in the chat is a README file which contains all the exercises that we're going to do. So if you want, you can move forward if you would like, but don't go too much forward because, well, you're different from the other trainees, and maybe you run into some issues that I will explain later on. But for now, it's the idea that we're going to do the prerequisites. So everybody can install a JDK 11 or higher. I don't know if everybody already got it on their system. I certainly hope so. Likewise for Maven, if you have a Maven version below 3.6.2, you need to upgrade to a higher version. 3.8 is recommended, but maybe another version that will work as well. We're going to use Docker for a lot of exercises as well, and especially for the database. We're going to use a Postgres database because it's quite simple. If you would like, you could use a other database that you already have running on your system, but then you're on your own with the database scripts and that kind of stuff. And there are a lot of insert statements. I hope that they are all ANSI, so they shouldn't be a problem, well, inserting it to a different database like MySQL or an Oracle database, but you never know. I've tested it only on Postgres, so that's what we're going to use in the exercises. Then we're going to start up with a inventory service. You just go to the Quarkus website and create a new inventory service. Everything is on there. If you would like, you can opt to use Lombok. If you don't know what it is, maybe it's fun to play around with it, maybe not. Some people hate it, some people love it. It's up to you. I find it useful because it takes away a lot of plumbing for me, but it's not necessary. So let me share this link. I will stop sharing. And someday I will learn to copy paste stuff. I've put the link to the exercises in the chat. So I would recommend we're going to use a good maybe 10 minutes, 15 minutes to set up your environment. You can use IntelliJ or Eclipse, whatever you like. If you use IntelliJ, the non-commercial one, the CE version, the community edition, then you won't have a Quarkus service running. But when I will showing when I will show the code, I will use the CE environment as well. I will be running the Quarkus application just from the command line. That will work just as fine, maybe even better than running it into IntelliJ. And I honestly have no experience with running Quarkus on Eclipse, so that should be fun if you would like to try that. So let's get started. And if there are any questions, please shout or use the chat. I see that 2 persons have joined this meeting. I've put a link to the exercises into the slide. You haven't missed any crucial information yet. So let me just share the link again. I don't know how Zoom works with new joiners. But please follow the link on GitHub and do the exercises for the prerequisites and the Hello World in Quarkus. So for the people that just joined, I will recap briefly what we're going to do today. And then hopefully we'll have a better insight of what this training is all about. Mainly, we're going to focus on building 2 microservices, an inventory service and a shop service that are based on the Microsoft SQL Server sample database, which I've extracted and ported to Postgres. And we're going to build a microservice around that with all kinds of neat stuff like REST API, calling microservices, doing health checks, metrics, that kind of stuff. And all within the MicroProfile ecosystem. And Quarkus is just a MicroProfile implementation, which has some neat stuff built on top of that. So we're going to discuss that later on. All right, let's continue on with the next part. Like I stated in the chat, this training will be probably 95% or something hands-on experience. There will be some theory behind some of the parts, but mostly there will be learned from the exercises. If there are any questions during the exercise, please ask. You can do that in the chat or just come online on in a video call. Maybe your question is also a question that somebody else has. You don't know. So first off, there is a buzz term that's called cloud native. And if you look it up, it says something like cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds, containers, service meshes, microservices, immutable infrastructure, and declarative APIs. Jesus, that's a lot of buzz terms. What does that actually mean? Well, it means something like that your application is not very big, so it's a small microservice, for example, and it can run on a random cloud, just in a Docker container, for example. But what it translates to is usually called a 12-factor application. So there is a website that's called 12factor.net, and that introduces the 12-factor application manifest. And it actually describes very clearly how you should build a cloud-native application. So if you run through that, there is So there are 12 steps in a cloud native application or a 12-factor application. Firstly, they say something about the code base. The code base is tracked in revision control. Well, you probably already are doing that. But it also says that well, you have a single source of your code base, and that single source of code base you can deploy to different environments like production or staging or develop or whatever. The next thing that we're going to say is something about dependencies, that you should declare and isolate dependencies. So ideally you have, for example, if you're using Maven, you can specifically declare which dependency you are using. You can use, for example, a dependency plugin in Maven that will show you if you're using dependencies transitively. So that's a great word. So that means if you, for example, if you import something like Quarkus, for example, you probably get a lot of libraries that come along with that. For example, Guava comes with Quarkus, or maybe a Commons IO or that kind of stuff. They usually transitive dependencies, and you should declare them explicitly in your application, or at least that's what the manifest says. Then it says something about configuration. Store your configuration in your environment. That's usually the case for Docker containers, because, well, you can't really load a configuration file specifically for an environment into a Docker. Well, you could, but you shouldn't do that, because then you're manipulating your Docker container, and then it's not built from a single source of your application. So if you're changing the deployments by changing the configuration file that's inside of your deployment, then you're not doing strictly a 12-factor application. That should be done in, for example, in environment variables. That stuff you can change for example, in Docker containers quite easily, and you don't have to rebuild the Docker container, for example. Then the backing services, they say that you should treat them as attached resources. So if you have, for example, your application uses a Twitter API, then that should be some kind of URL encoding or whatever that points to Twitter. And if there will become another big Twitter clone or other Twitter thing, then you should be able to replace that service quite easily by just changing the resource that's attached to your application. Usually done by APIs, for example, that you're going to use. Then this one, I think it's more in the region of the source control with build, release, and run. They say that they should be strictly separate build and run stages. So your code will be built and then deployed to a specific environment. So as the code never changes, then you should be able to say, well, this application we just built from source, it didn't change anything. The source code is identical, so that the build package should be identical as well. So you could move that between different stages in your deployment. Then your application should execute one or more stateless processes. And the key factor here is stateless. Your application shouldn't run or shouldn't have any state in them, because state is really bad in this day and age, especially in a Docker container in a cloud platform. Then you don't know when that container is being killed. So if you have state in your application, you don't know when your application is being killed, You could lose that state at any time, so it's really bad to use state in your application. If you must use state, well, most applications have some state in that, then you should use a database or whatever to store that state, but your application itself should never hold state. And then the port binding, also something more in the region of the Docker containers. You should expose your service via port binding, so you should explicitly say my service is running on port 8080, for example. And then almost there with concurrency. You should be able to scale out the process model. So you should be able to scale in both directions. So adding more service should be able to handle more throughput. Deploying the application on a bigger server should also allow you to handle more throughput as well. Disposability. Like I said before, your application could be destroyed at any time. So you should be able to start up a new application quite rapidly. And you should be able to handle a shutdown as well. So if you have a running process, you need to, well, either discard of the information that you're using, or have a shutdown hook that writes the information about that process away, so the new instance can pick it up and restart your process as well. And there is something, number 10, dev and prod parity. Well, just like before, if you're building your application for every stage from the same source code, it should be the same. And so should be your environment. So you shouldn't have, for example, a dev environment that runs a Docker swarm, then you go to acceptance, and then you're running on Kubernetes, for example, and then you're going to production that runs another cloud platform, for example. That shouldn't be the case. All the stages should look very similar, or should be as similar as possible. And then logs should be treated as event streams. You usually write logs to a log file, for example, and you could use for example, in Elasticsearch, you have a listener that will listen to your log file and writes those log statements to a centralized logging framework, like Elasticsearch, for example, or there are numerous more. But the log files, the log that is actually written on file, should be outputted to somewhere else as a event stream that could be picked up and that could be read in a centralized way. And if you have a admin process, for example, clearing out errors in your database, for example, or whatever, that should be a one-off process that you could start. So your application starts up, does the admin thingy that it needs to do, and then shut down again. So a normal process will not have the admin process inside of it. And it was briefly the 12-factor application. If you want, you could go to the website and read all about it. The information is quite well, extensive and quite complete. So, if there are any questions, please ask them. If not, then we're going to continue. So what is Quarkus? Quarkus is a Java framework / build augmentation tool that is tailored for hotspot and Graal VM, boosting extremely fast boot up and low memory utilization. Well, great. That's also a nice management bullshit bingo of all kinds of cool terms. what it actually says is that its argument uses argumentation inside of the build to make stuff faster. That translates into some weird quirks with Quarkus. If you, for example, were developing your application onto a Oracle database, and then would package your application with that Oracle database in mind, and then to try to run it against a Postgres database, for example, then it would fail because it would have built in the Oracle database stuff and would not have packaged the Postgres drivers, for example, to use in your Postgres environment. So those things are determined on build time. So you can't change your database, for example. There are other stuff that's being done upfront. So Quarkus tries to do as many things upfront into the build stage as possible to create faster boot up times, because everything that's determined in your build phase will not have to be determined when you start your application. And well, that allows for faster boot up times, but that also means that it can be better in creating native images, because if you want to create a native image, that's the application. You normally run your application inside a Java process, but with a native application, the Java process is no longer there. It's just executing the bytecode directly on your system, so there's no Java runtime anymore. But if you want to do that, you need to know exactly what you're going to need upfront. So that's also something that Quarkus does for the build tools. Let's gather as much information as possible of what's going to be used in runtime, so it can be packaged into the native package. So don't have to package all the kind of drivers that you might not need, and that will allow for smaller binaries, faster build times, and well, faster boot up times, and that's exactly what it's all about. For example, if you start your Quarkus application, maybe you've seen it in your Hello World application, will probably start around 2 seconds or so. But if you create a native image, that will probably start in 2 milliseconds or something. So that's really, really fast. And it's great for microservices because you can scale up quite quickly. And it's also a MicroProfile implementation. So I'll be using, I've used MicroProfile a few times now. So what is MicroProfile? MicroProfile is a set of specifications that is used in the Java Enterprise world to build applications. And the Java Enterprise edition is quite big, has a lot of specifications in them. A lot of stuff is not used for everyone. So what I try to do is create a microprofile of the specifications that are used most frequent and are used quite well together. So for example, you have open tracing, open API, a REST client, configuration 2.0. So there's a lot of things in there. But what we will mainly be using is Jakarta CDI, that's container dependency injection. Gonna touch upon that a little bit later. And probably going to use some configuration for your application. Maybe use a REST client. That's exactly what we're going to use to call our other application or other microservices. So our shop service will call the inventory service using the REST client. The authentication, if you would like to secure your application, and you can use the authentication. Metrics are quite useful to see where your application is going. So that's the set of specification that's inside of the microprofile specification. There are the specifications are updated quite frequently, and so is microprofile. So I believe currently we're on microprofile 4.2. I don't know exactly, but within Quarkus they have decided to use microprofile 4.0. for their 2.0 release stream. And I haven't seen any updates yet, so they haven't updated to the new specifications. And Quarkus is also a main contributor within MicroProfile, so they are actually contributing to the ecosystem of the specifications. That's quite nice. And I must say, they haven't quite implemented all specifications to the letter. So you will probably see some caveats here and there in the README that some things will work or will not work, depending on what state they are in. And sometimes the documentation is a little bit outdated. There was a specification, thinking about what it was, probably something with JPA, that were saying that something was not supported because there were many people using that feature, and when I tried it, it just worked. And a few versions later, they updated the documentation to reflect that. But sometimes the documentation is lagging behind of features that are implemented. So, and Randy says that MicroProfile for the DO is based on Jakarta EE 8. Yeah, so the Jakarta namespace is not there yet, so they are still using the JAVAX namespace. So that will be a big update. Probably with Quarkus 3.0, that probably go to the Jakarta namespace. Any questions about MicroProfile? We're going to see a lot of the specifications in our exercises, so, or at least the things that are used the most. If not, then we're going to continue on with CDR, the context and dependency injection, or container dependency injection, depending on you're asking, is a standard dependency injection framework that's been included in GA 6, and it's also in MicroProfile as well. And it allows to manage your lifecycle of your components. So what you can do, I heard that some people were using Spring or has some experience with Spring. So if you're using Quarkus, you have something, you have beans that you could define, and beans are well, things you can inject somewhere. And if you want to inject somewhere, you can use the Quarkus inject, or that's exactly the JAVAX inject. And with EE, that was the @EGB annotation. And in Spring, that's the outright implementation. Now, if you want to use a bean that is stateless within your application, in Quarkus, you can use a application scope bean. That was in EE, was it a stateless bean, and in Spring, it's a component. There is something called a singleton in Quarkus, and it's not the EE singleton. So in Java EE, there is a singleton that is a bean that can be called only with one thread. So only one thing can call that service at a time. So it's quite log heavy. But in Quarkus is something different. It's also a different annotation, but it's a application scope bean without any proxy. So I don't think everybody knows what a proxy is. When you define a bean, the application will create a proxy for that class. In a proxy, there are many things going on. So you can it wraps your methods with, for example, things like transactions, things like the metrics that we're going to see later on, and all kinds of that stuff. But that's not the case for a Quarkus singleton. It's just a plain class that's being injected, so you can't use trickery like mocks and that kind of stuff on that. but we're gonna see that later on in the exercise, I believe. And then you have two more scopes that are relevant within Quarkus, and that's the request scope and the session scope. The session scope was a stateful bean in the enterprise world, and I don't believe there is a request scope, or anyway in a traditional EE application that's being used for in a request. So if a client fires on a request, then you have some context for that specific request in your application. It's usually not that useful because you can usually translate that state, or if you give the service that you're trying to call that specific state that you're probably gonna need. But if you want, you can use a request scope. Session scope is of course quite useful, but it also means that you're gonna use state in your application. So you have to manage that. So either write that state into a database or whatever. And then if the callee calls your service again and that state is still there, then you can use it, but otherwise you need to grab it from the database again. That could be useful as well. But mostly the beans that I've been using are application scoped, because there's just there's just one bean for that specific class. So what does it look like? For example, I have a translator service here, totally unrelated to our application. That's an application scope bean. And there is a dictionary, probably also has a application scoped annotation on that. And we can use that dictionary with a @inject annotation. And then, for example, we can call the dictionary service in this translate function. Alrighty. Questions thus far? If not, then we're going to continue with the Open API specification. It's also a bit text heavy, but what it actually is a specification that will allow you to write documentation for your REST API. So you usually have quite a lot of functions or methods on your REST API, and with Open API you could document exactly what is required as input parameters and what comes out, status code that you can expect, and that kind of stuff. It's quite useful. So what does it look like? That's probably more descriptive than the text that I had before. For example, if you're using a REST API, then you have something like a public response get username that returns a username. So that's a get method. This @get annotation is from your default REST framework. The path is something that's also required from your REST framework. But then you have your operation. Here you can give a summary that's going to be used inside the documentation. You can define your API response. You could say from, hey, this is the user, and the content is of type content of JSON, and it has a schema that's been defined by the user class. And maybe another API response is a 400 code if the user is not found, for example. Then you have your username. That's a parameter inside of your get call. That's it's actually called slash and then the username. Then you can define some documentation on that username as well. And again, you need to define here the path parameter for your username. And when you implemented this, then you have something like this. This is a pet store example. And I can't zoom in, so that's great. But you will see this in your exercise. Swagger implements the OpenAPI specification and creates a UI for that. That UI you can access in your application. It's default packaged when you're developing your application. So if you're running your development profile, then you can access Swagger. But in a production environment is off by default, because it also gives a lot of information about what all the operations are on your application. So if you don't want it in your highly secure application, then it's off by default, and well, you can turn it on again if you would like. But it's quite useful because you can just play around with the UI, see what all the methods are and how you should call them and what the responses are. So it's really nice to have API documentation, especially if you're developing microservices and developing microservices in a bigger environment. So there are some types of testing that we're going to use in the exercises. Of course, there are some default unit tests, just plain old JUnit 5 by default. There are some Quarkus tests. We're going to see them later. Those are integration tests, and that Quarkus test is a way to start up your application, but inside a smaller container. So it's using, for example, the in-memory database or a random port, for example, and then you can access your beans directly. So you just can call the service that you would use, and then it can eject all the stuff that it would need. So, for example, all the dependency that it's using. It's quite useful, and you can also mock out specific parts of the application. So if you, for example, have a service that calls a other application via REST API, they probably would mock out that specific part with a Quarkus mock, and then well, mock out that response and not do the actual REST call. And then you have something called rest assured testing. That's based on Quarkus testing. So you still start your entire application, but you will more or less handle it as a black box. So you would just call the API as a normal user would. So don't call the specific services anymore, but just use the REST API for that. And that's also quite good to see if everything still works, because if you would use a Quarkus test to, for example, to test your the service that would call the get user by name, then you could just play around with the response object in there, but that's quite finicky. But if you're using the rest assured testing, then you're actually testing the actual result that's coming over the HTTP line. That's quite useful. And you could still use Quarkus mocks to mock out specific parts of your application if you would still require that. Already, the data model, I'll be showing that later on again. But in the entire database, there's something for sales. We're not going to use that. We're not using stocks anymore, but we do have some products, we have some categories, and we have some brands. And that's something for the inventory service. And those three entities we're going to create in our inventory service. And that's exactly what we're going to do. We're going to create a REST endpoint, document the API with the OpenAPI specification, and of course use Postgres to load up all the data. And let's see how we're going on time. So there was a question about checking the return values of a Quarkus test, or at least a rest assured test, other than string comparison. actually, there is a reasonable way to do that. And that is with the rest assured API. Then you can do stuff like this. For example, I want to check if the product size is 1. So I can do a given when and then slash products. Well, the status code check is one of those things in rest assured, but I can also check the body. So I can check the size of the body, but I can also check specific fields in the object. So I can check that there is a name called best thing. So I don't need to do a comparison between or a contains in the.
Sorry, sir. I think you are in a wrong screen. We are seeing the presentation.
Sorry, I don't have. That's correct. I don't have the thing. I need to share my entire desktop. Rookie mistake number 1. Now you can see the IntelliJ, right?
Yes.
Yes. So, and again, this is the given when then structure for rest assured with status code and the body size check that it contains at least 1 item. And then within that namespace, I got the best thing as a result value. Hopefully this answered the question for everybody, but maybe you can do some more stuff with this as well. For the people that are a little bit ahead of the exercise, maybe it's fun to make Quarkus start up slowly. For example, if you look up, you might need to search online to create a startup hook and put a sleep in there, a sleep for 5 seconds or something. Then Quarkus needs to, with the hot reloads, need to reboot the entire application. There's also the startup hook. And then it will take 5 seconds. And then it's starting to complain that it will take too long to restart in a hot restart mode. And it will give you an hint to restart or instrument your code and then only restart the part that has been changed. That's also something, maybe just for fun and look at it and play around with it if you do got some extra time. So hopefully those who hadn't responded yet, maybe can listen it back or maybe read it back. So let's start with Hibernate Panache. Hibernate Panache is a framework that supposedly simplifies Hibernate for Quarkus. It's a framework that explicitly was designed for Quarkus. So it isn't a microprofile specific part. It's also not a specific specification or something. It's really an addition of Hibernate. And with that, you can create entities that respond like resources. Maybe for those who work with Spring, there's something I believe called data source or something with data, and there you can get some repositories for free. So you can get a find all, persist, merge, update, that kind of functions for free. And that's the same thing that goes for Hibernate Panache. So for example, according to the documentation, you have 2 solutions. The first one is called the active record pattern. And this is where you extend a entity with a Panache entity. A Panache entity has by default a ID with a long value. If you want to use another ID column, you can, but then you need to extend, I believe it's called a abstract Panache entity, and there you can define your own ID field. But this way, if you define it by this, you don't have to do anything else with this class. You can now do all kind of cool stuff. For example, you just can initiate a new person, and then you can call persist on that person. That's really useful. Let me see if I can zoom in here a little bit. You can persist the person. You can also check if it is persisted. You can delete it from the database. You have a list all function, find by ID, find by ID optional, all kind of cool stuff that comes right out of the box. And there is a way to do that with streams as well. So it's really nice to have a really quick and dirty way to have entity persisted in the database. However, mocking those and using that in the unit test is a little bit finicky. It is possible, however, there are some ways to test this, but I like the other way, and that is the solution 2, using the repository pattern, and that's almost like the one that is being used in Spring. So in this case, we just have a normal Hibernate of JPA entity. In this case, a person. Do note that you need to include the ID here because, well, it is no longer free of charge with the extent of the base entity. You could create your own base entity, of course. And a lot of getters and setters. And then in the repository itself, you can just create an application scope bean. For example, in person repository that implements a interface. In this case, the Panache repository, and you have to specify which generic pattern it uses. Generic type it uses. So it's a person. So this Panache repository now has a lot of functions specifically for person. Of course, you can extend that because you can just call the defined method that's in the Panache repository interface. And then you can just inject it as a normal dependency. And then you also have all the methods that you could have on when you extended the entity are now available on the repository object. And this repository object is way more easily mocked than any other or the other solution. So I do like this this way of creating repositories for Hibernate. And as you can see, the same method calls are available. That's it for Hibernate Panache. In the exercise, you're going to play around with it and well, see for yourself. If there are any questions, please put them in the chat. Next up is Liquibase or Flyway. What you can do with Hibernate is set the schema generation to automatically. So if you add a new entity class, Hibernate will then generate its own tables for you. However, this is not something you want to do in production. You probably want to use some scripting for that. And there are two solutions that come out of the box with Quarkus, and those are Liquibase and Flyway. I've worked with both. Both are really good at what they're supposed to be doing. Liquibase is a way to track and deploy database changes, and that's the same thing goes for Flyway. Maybe the Flyway website look a little bit more dated than the Liquibase one, but well, it shouldn't matter. The only difference is that Flyway has a way to automatically version the database according to the file names of the scripts that you're using, and with Liquibase you have an XML file that you can use to version your database. And Liquibase also has a function to generate scripts based on the database that you're using. So for example, if you're using a Oracle database in develop and Postgres in production, Liquibase can handle those changes. But however, like I said before, Quarkus can't do that because it binds the database source that you're using in the build phase. So you can't change it afterwards. However, you can use it before, for example, to create H2 scripts that you can use for an in-memory database. But why should you could also use the Hibernate auto generation of the schema. And for both Liquibase and Flyway, there are Quarkus extensions. So for example, if I look for Flyway Quarkus, then there is a nice guide for this, and Liquibase, and for Liquibase is the same thing. So choose what you would like to learn. Maybe Flyway is a little bit easier and faster if you're not familiar with both, with either one. Liquibase is also a nice option. So those are the exercises for now, for until 2 o'clock, to use Hibernate Nash to create your entities, implement the database according to the schema, and use Liquibase or Flyway to roll out that database. And the database scripts are linked in the same repository as the README. So there is a folder here, Postgres, that contains the correct scripts, but they're also linked in the README. So if there are any questions, please put them in the chat. And otherwise, good luck with those exercises. Alrighty, I hope that everybody is finished with the exercises, or at least close to. We do have some time, I believe, at the end of this day to finish those exercises, but this time I'm gonna hand it over to Rudy.
Yes, thank you. So, start my screen sharing, I guess. For those that followed last week introduction, the fundamentals training of MicroStream, there will be, of course, a lot of overlap with what I told there. It will be, of course, a condensed version, but yeah, the same things we will cover here again, of course, than what we covered last week. But there is also, of course, a focus on Quarkus, how you can use it within Quarkus with or without integration. Come to that in a moment. But yeah, if you have any questions, especially for those that did not follow that training last week, please ask. You can just unmute yourself or put it in the chats. Make sure that I can see the chat in a moment. And then, of course, we can go more in detail into your questions around MicroStream. So the traditional Java application, I would say, is you have your objects within the JVM memory, but your data is stored externally, as in that example that you hopefully all created the last few hours, where you store the product, for instance, in that Postgres database, and you read them in with Hibernate, pure with Hibernate, or here now with Panache. You always need to retrieve the data externally in an external system. And that external system has also a specific format. You have the relational database, the tables, fields, rows, etc. Whereas the JVM, that is using objects. We have the object graph, we have properties there, instances of Java, and so that is not the same. What we have seen with many applications is that the fact that your data is stored externally, so that you have to that you have that latency. Every call to another server in the same network, that puts some overhead to get those data. So you have that latency, which is of course much higher for those external systems, a database, but it can be no SQL solution or any kind of solution. Is always that latency is always much higher than just accessing your data within your JVM memory. And we have also here the conversion. We have that that entity behind the scenes. Hibernate converts the values that we retrieve from the JDBC through that JDBC layer, where it's mainly, there are a few others, but mainly just numbers and strings and dates, etc. It converts all that the flow of all those data back to objects, which can take some time. And that's also why, and that's a bit funny if you look at it afterwards, that the JPA specification explicitly mentions two types of caches already. You have the first level cache and the secondary level cache. So that means that they have foreseen that JPA has some performance issues. So looking at all those facts, we might have for many applications, we might have a better solution than getting your data always externally as the primary source. If you want to look up more about those, what's called impedance mismatch, the differences between the relational database and a object relational world, and then you can Google and you find a lot of information on that impedance mismatch, and there are even 6 or 7 different levels of it, so 7 different aspects of it. So instead of having within your application a data conversion layer there in that orange red block within your application, data conversion object relational mapping layer, which can be quite large. In that simple example now, where we just read some products, that's fairly easy, but you have more complex scenarios where you have compound keys, where you have that object, where you have an object hierarchy mapping to subtables, etc. So going through all the features, etc., that takes some time. There's a lot of things that you need to learn around that, and it's also at runtime quite some resource heavy, just to read your data from tables or NoSQL, or even a in-memory data grid, which is running on several machines throughout your network. Main point is everything is external, so that's the idea of microstream. Your JVM memory, your objects in memory are considered as the database. Of course, you need to store it somewhere, because if your process dies, then you would lost all your data, which is of course also not a good thing. But the main idea is that data, your database, are just stored in the JVM memory and part of your application, which means that it is easy to access them. You can just use getters. You can use the stream API. We call the Java stream API, in fact, the query language of MicroStream. It's pure Java, so reading those objects, we don't even care about it because they are just Java objects. But all those pure Java ways, that's of course is fast. It is in memory. There is no conversion needed, which means not only at runtime it is faster, but also the development development time of your application is smaller because it goes faster. MicroStream is actually a few classes. In 90 or 95% of the cases, you only need to access like 5 or 10 classes and maybe 20 statements, 20 methods, and that's all that you need to know. As mentioned, you need to be able to store your data somewhere. So the primary source of your data is the memory, but you need to have somewhere a location where you store the data, where it is read when your process starts, where everything is loaded again in memory as it was when you stopped your application. And that's where MicroStreams comes in, where we have the next generation Java serialization engine. So it is completely new. It's not the Java serialization of Java, because the idea is that you can have any kind of Java object as part of your database. So not only those Java instances, those Java classes, which happens to implement that serializable interface. So that's one major point, of course, that we can use any kind of object, any kind of instance, that we are not limited to some subset of classes. Of course, the fact that to how the Java serialization work in Java itself, then you have many security issues that will also, of course, the reason or a good reason to create something entirely new, which is using something else as the basis. So we are only restoring data. So we are not calling any kind of method. We are not calling the constructor. We are not calling any kind of initialization method that you might have in your class. So this purely direct generation of your Java instances on the heap. So we use very low level Java APIs that create that memory address and that points and that you can have a Java variable or property pointing to that Java object. So instead of then reading the data from that external source as the primary, that external source is the primary source, we are reading it at startup from just a plain file storage in a binary format, but also we can use a database, but then not storing the data as fields and rows, etc. We are just storing it as a blob in a database. Or we can also store it as a blob in any kind of other system. For instance, event streaming, you can push your data into a Kafka stream, for instance. That also means that we have reduced that large block of the mapping and the object relational mapping, the conversion, etc., to a very thin block of MicroStream. As I said, 5 to 10 classes, 20 statements at max. That's what you need to learn. So let's see it in action. How do we do the configuration? How do we read the data then? All the aspects, and also how can we integrate it within Quarkus, for instance. So this is the same as last week, a few ways on how you can configure MicroStream just in plain Java. So this is not yet using Quarkus. I propose that you first play around, at least at the first few hours, that you just play around in pure Java so that you know the different concepts, how it works, and what is needed, like the minimal steps for the configuration. And then once you know those things, then you can make the next step make use of it within Quarkus, for instance, and then use the specific functionality that we provide, for instance, with the integration, which is not officially released, but more on that in a moment. Mainly, there are one, or in this case two, dependencies required to make use of MicroStream in your application. Since MicroStream is not an external system, it's not like the database that you have running somewhere. This dependency that you add to your application itself is the only thing that you need. It's not that you need some external system running somewhere. This is required for the configuration. If you are using external, that you read the configuration from external files, for instance, which is, of course, recommended, that you don't include it within your application. So these are the two main dependencies. If you look then the dependencies that end up in your application, then you only see a few MicroStream dependencies, except for that SLF4J API dependency here, because the logging, that's the only thing where we depend on something externally. And SLF4J logging is more than flexible enough so that you can fit it, fit it in your application. And all the rest, we only use our own code base. The reason for that is that, for instance, we do not like to use Apache Commons or Guave for those utility classes, because then you might have a conflict if you are using those dependencies also in your application. So then again, you might have some additional work to fix all those dependency conflicts, etc. So that's the reason why we have our own utility classes specialized for what we need. So there are no cluttering. There is no 100 or megabytes of data of additional dependencies that comes in. It's all very small in the few hundred kilobytes in total for the entire MicroStream code base. A few examples of how we can do the configuration. So when we configure what's called the storage manager within MicroStream, which is responsible for loading it if there are already data from the external storage, like a file system we are going to use here. The storage manager is also responsible for if you want to save something to that storage. So configuring that storage manager, you need two things at a minimum. That's the absolute minimum. Although we also have a default for the location where it is stored, but probably you want to define yourself where which directory will be used to store the database. Again, it's just the binary representation of those Java objects that are used when you start up your application again next time, or for whatever reason you have made an update, you have added an additional functionality, then you can read, of course, the data from there again. And the other thing is that you indicate one root object. That's the one object of an object graph, one instance of an object graph, which is which is considered your database. So the object graph is considered your database. You need to point one instance from that object graph. You need to tell MicroStream which that instance is, so that he can traverse the entire tree, so he can follow references, etc., And at the end, he will have access to the entire database, the entire data set that you want to manage. In this case, the root object contains a list of users and a list of books. So it is not a real example of a library, of course, but the idea is that you have some books and some users who have borrowed books so that you know where a certain book might be. So that's are the two minimal ones, the two concepts at minimum that you need. And you can just start the storage manager. So the this is here an interface. This is more or less a kind of builder pattern where you just specify that root and that path. And then we make sure that there are some initial data for testing. So from that storage manager, you can retrieve the root. Here it's used to supply the root itself with the storage manager, because the storage manager, you need to store data. So that's the reason why most of the time you assign this storage manager somehow within the root. More on that also in the Quarkus specific example. And if we see that there is no data yet in the users, we assume that it is an empty database. Then we add the default. If there are already data, then we just log out a message that there is nothing to do and that we have already users. And then I have added here 13 books with ISBN number, name, author, and some books are assigned to users. I will put the link to the GitHub repo where you can find this example in the chat in a moment so that you can play for it with yourself. This is just about configuration, so I'm not going to update it, not going to change the data in any other way, just print out the number of books that we have. So this is the first time that I run the program. So it should create the data, and it should print out that there are 13 books in memory at that time. And you see here info adding the default data, so it was the first time it was empty. By doing that, he has created here the directory, because we have defined simple config, not an absolute path, but a relative one. So he has created here within my project. And I have here channels. Short word on channels, when the data is stored by the storage manager. So when it is converted in that binary format and saved to file, then a certain thread is responsible for that. By default, there is only one of those threads which receives from the storage manager itself of, hey, please convert me this user, for example, convert me this user in a binary format, and then store it wherever it is needed. Here we are using disk. As mentioned already, you can also use database and Kafka and whatever. It might be that you have to write a lot of data, or when you're reading at the first time the data, that you have a lot of data to read in. So then it is beneficial to have more than one channel, so more than one thread that handles that load. So in one of the next examples, I can show you how you define multiple channels so that you can speed up that process a bit. So let's run it now the second time. We have all the data here. Yeah, this is the binary data. You cannot make much out of it. This is also, this is called a transaction file, but actually not really needed because you can just delete that file. That's more about to keep track of what the storage manager has done, and yeah, you can safely delete it. It can help experts like the MicroStream developers, for example, to see what's going on if they see something odd or if there is an issue. This persistence type dictionary is a conversion table, basically very important. If that's one is corrupted or deleted, whatever, you have lost your data. Because there, because here in this binary format, we have identifiers saying a certain number, this is a list, this is a book or whatever, and then the data itself. So we store it in that way, store just pieces of the information. We don't store class information or etc. We just store pure data. And this type dictionary is then the mapping to, for instance, our book has these properties of these types, and in that order they are written into that binary file. So if I would for fun change this one, then reading the data again would just have swapped the ISBN and the name field. So then you would see funny results, of course, which is not the intention. So this is a file maintained by MicroStream, which is also very important together, of course, with the entire binary data. In the meantime, you have seen that we have the output. It mentioned now there is already data, so it does not need to read to create the test data, and that you see that yeah, we have, sorry, if you would put, no, I don't have the output of the first run anymore, but you would see that the data is identical to that first run. So we have successfully retrieved the data as it was at the end of our first run. Any questions about this? First thing about MicroStream was trying to find the chat between all those Zoom windows. Yeah, as I said, those people who followed the training last week, they all know it by now. This is the simple way, but most of the time it's not the way how you should use it within your application. Even a Java SE application. Normally you create a storage manager through the builder pattern. So we have a builder pattern available, and this actually, that pattern requires that additional dependency, that embedded configuration dependency. So that's why it was there in the project, but most of the time you will use something like this or the more advanced one, which I come to in a moment. And in that builder pattern, then you specify each feature, each functionality. You configure each functionality through a method on its own. So the directory where the binary data is stored, you can just put it, you can just set it with the set storage directory. You have now a method which defines the channel count. It was 1 in the previous, now I'm setting here as 4, which is for this kind of application, of course, way too much. 1 is even more than enough, but this is how you can do it. And then you create what is called a embedded storage foundation based on those configuration settings. What is a foundation? That's for us, it is a class that contains all the data from which you can create the actual object later on. So we have a few foundations. The storage foundation is, of course, the most important one. So through that builder, you create that foundation, which is the blueprint for creating a storage manager, because there's probably 20 or 25 different sub-modules that you can all configure. You can even replace them because they are all interfaces. And for instance, on that foundation, one of the things that you can do, you can, for instance, register additional handlers. And a handler is a piece of, for instance, I can add some custom type handler or whatever. A handler is a code piece, a class that converts, for instance, your Java object to that binary representation. By default, MicroStream already provides all the required handlers, of course. Some of them are generic. That means that they are not optimized until the last bit. So it might be sometimes good. For instance, we have already specific handlers for those JDK 8 collections, for instance, or the new collections, immutable collections, which are available in JDK 17. So it might be good that you add handlers for those types. So that's something that you can do on that foundation. You have the possibility here to register new handlers or customize that foundation in any way that you need to customize it. One of the things that you also set, that you also define on that foundation is what is the root? What is that root object? So that is something that you can put here also. And then based on that entire configuration, you can create an embedded storage manager, or in short, a storage manager out of it. And don't forget to start it, because just creating it means it is not running. The data is not loaded. If you try to save something and store something on a not started storage manager, you get an error because it's not started. So don't forget to start it. So actually, this method with these two parameters, behind the scenes, it is calling something like this, where it sets the storage directory, where it sets the root, and it creates and starts the storage manager. This is a more common way of doing it programmatically. I can again run the same example with those 13 books, but it is exactly the same. And I'm adding the default data. You also see another few other loggings through that log4j of the main steps what MicroStream is doing. In debug, on debug level, you see a lot more. Then you have every detail, including the registration of those handlers, reading the root, etc., and all those kind of things. That's the programmatic way, but also, as mentioned this morning, if you think more about the 12-factor type of applications, of course, you can read those values first from any kind of source and then pass them through this method so that it can be created. Or, of course, you can immediately read everything from an external file. an external configuration file. By default, we support two files, have two file types already, which is a property file, the classic key is value pairs, or the XML one, where we have tags, a property tag with the attributes name and value, which of course just corresponds with that key value pair in the properties case. Again, these are the two default implementations. Everything is an interface, so you can even create your additional format, like say YAML. For those who like YAML, not everyone is a fan of YAML, of course. Reading them, those files, is then more or less the same as the builder pattern, except that the builder, instead of using that builder, now you load that external file. Once those data are loaded, which the data that we have set programmatically first, like that directory, the channel count, etc., we have now used the external source to read them. Then from that point on, it is the same. So we can create a foundation again. We set a root. We do the customization, like those additional handlers. We create a storage manager and we start the storage manager. So that pattern is almost identical to the one that we have seen with the builder, but now we are reading the values from an external file. Properties, storage XML, it does not even matter because on purpose I've created exactly the same configuration within this properties files as in the XML file. So now with this was using the XML file, he has created the data here in the external config. So there is now two channels used. And if I switch that, of course, to the properties file, then it can be used, of course. There is no reason why the same configuration from different how the way how it is obtained, that it should have any impact on how the system works. See, he can just read the data. Data is already available, nothing to do, and we have our 13 books in this case. Any questions about the usage of the configuration in, let's say, in most cases, especially if you're not using an integration like the Quarkus one, or any kind of any other integration, how you use it either programmatically through the builder or through a files or an external resource in general. There's one option that I should mention just for the sake to be complete, but this is the very long way of creating that storage, that embedded storage foundation. The long way, so that you explicitly need to indicate for each submodule what is the actual implementation. Because I said everything is an interface, that means that you need to indicate what is the implementation class. So we even indicate here, okay, we are going to save something. We're going to store a file. Through which system is it? We have internally, we have that what's called the abstract file system, AFS, which abstracts away where the actual storage is. So is it on disk or Kafka or whatever? So core microstream does not know that. It just knows the abstract file system and knows how to interact with that. So writing and reading, it's a bit more involved than just that, but in a few simple words, it's that. So that means that you need to specify an implementation. So yeah, we have here not a new keyword, but we use a lot of those static methods as an alternative for instantiating a certain implementation for a certain principle. For instance, the channel count is provided by an implementation, and we provide the implementation here with a value of 8. We provide the storage file provider with a certain file system, which is the non-blocking I/O. The non-blocking I/O file system can be the SQL one, it can be the blob one. We have also a blob file system for storing to Kafka, for instance. Then we provide all that information to that extended way of creating that foundation. There are even more methods here. So this is the expert mode, I would say, where you define everything up to the last bit and byte, how the things should work. But again, the end result is the same. You have here, for instance, I define here the class loader, but again, that's just on that storage foundation. You can do that also in the two others. I can have those binary the binary handlers for the specific JDK 17 things. But at the end, you create, out of that foundation, you create a storage manager and you start that storage manager. Always the same principles, but going from the small, easy one to the very elaborate one, like this one. So assume configuration is clear for everyone. Remember, the most important thing are these two things. And that is, you need to specify the root object and the location where the data is stored as a fallback for when your process stops. So a few remarks about what are the core things, what you can do, or how you should use MicroStream. First of all, just use pure Java to query your data. So I mentioned already, the Java Streams API is the query language of MicroStream, because you can read a lot of, you can find your object easily based on the Java Streams. You can also use for loops and if then else and whatever. If you don't like Java Streams API, then it's no requirement, just pure Java. You need to configure the storage targets. That's what we have done already. We have seen a few examples. I'll explain a bit in a moment how you can store things, because now we have just configured it, not that we have to make changes. And the golden rule is store what is changed. And actually, that's not really different from what you do with, for instance, with the database. There you update a certain record, a certain entity, or you delete in a certain one, or you insert one. There are a few specific things around that with MicroStream, but same rule applies. Store what is changed. If you don't do it, then you have basically lost the data when you restart your application. use something called lazy when you have details with many data, historical data. I briefly cover that. We have integrations for runtimes, like the Quarkus one, which I will show you. It is included within Helidon and Micronaut. So if you are using Helidon Micronaut, okay, you are not because you are here in the Quarkus one, but if you would use Helidon Micronaut, it is even included. You don't need to add it in your application microstream. It is there already within the runtime. Of course, we only briefly touch it, but everything in the open source version, which you can just use by including the dependency, is used for one single process. One single JVM is linked to one storage. So it's a one-to-one thing. So clustering is in theory possible, but you have to write many things yourself. So that you only so that only one JVM actually writes and reads from a certain storage. So therefore, we have the MicroStream Cloud, which is enterprise, which is currently running on AWS, which is Kubernetes-based, and where a Kafka event stream is used to distribute that object graph. So it's like a cloud solution. You have a UI, you specify this is my app and my GitHub repo or my file. You can run any kind of file there, Quarkus even, Micronaut or whatever. And then he sets up the entire cluster with auto scaling, etc. So, and make sure that, yeah, of course, the entire thing works based on a standard storage manager. Which use cases do we see most suited for MicroStream? But basically, your imagination is the limit. You can use it wherever you may see it fit to use. One of the things is with the microservices environments at the local cache, because with those, most of the time, microservice environments become now so large that it is no more feasible to, for each call, for each request, send calls to 5 to 10 other microservices to get your actual data that you need for request, because again, that latency is hitting you there. All those calls adds additional overhead, so that means that it's becoming very slow processing your request. And the solution is that a lot of companies are using local caches. So each process has a cache of the most important data, so that it does not need to go look for the actual values within the environment and within the entire microservice environment. Those local caches ideally can be also made with MicroStream, of course, because the advantage is that when your process starts up, you have a warm cache, you have all the data again. And that local cache can be updated through an event system. If somewhere is made a change, then you broadcast out an event, and you capture that event and you put the data in that object graph. And if that's maintained by MicroStream, then it is also available the next time you start your microservice again. Second one is serverless, where you start up your process, not all the time, but most of the times you start it up with minimal set of data. So not going to detail of that lazy, but remember to use lazy there a lot so that you have a fast startup. Your storage manager does not need to read a lot of data, but your request can then can access those lazy data when needed, and then you have a quick and efficient system. There are already several examples of that, how that microstream in this serverless setup makes it very efficient, and data can there be stored, for instance, in an S3 bucket next to your application. Again, watch out for latency issues. And then, of course, you have a nice solution there instead of using a database in that serverless environment. And the third thing is the mobile development, the offline storage. Most of the time, SQLite is used for that, as for if there is a mobile application which is not always connected, then data is stored in that SQLite and then synchronized once you're online again. But it is much easier to develop and to program with MicroStream, because you just need to make sure that you store your changes so that it is stored on the device, on the storage of the device until you are online and can do the synchronization. Not only limited Java, works in GraalVM also. We use reflection, so you need a bit of configuration there. But for instance, Micronaut and Helidon are using it also in the GraalVM version, so it is possible. And it is pure Java, so that pure on the JVM, so you can use it in any JVM language like Kotlin, Scala, Groovy, or any kind of JVM language. It runs on the desktop, of course, but also in the clouds, containers, microservices, Android, as long as it has JDK 8 or higher. This version, MicroStream version 8, will be having JDK 11 as a minimum requirement. These are the list of databases, NoSQL's, object stores that we support for the moment, besides the disk one, but it's an abstract file system, so you can implement your own version, of course, if you really need it. For the time that I have still some time, so for that time, I'm going to show a few other features like the CRUD one. So actual storing data to an external system. If there is any question, please interrupt me. Otherwise, I can just continue. I will put all the links in a moment to all these examples later on. This one is actually one which is not yet available on GitHub. Similar ones are available, but this one was specific made for this course, for the Quarkus course one, and it was the adapted one from the CRUD one from last week. This one is not using the integration, so I'm just using the pure dependencies, the embedded and the embedded configuration, as we saw in the config ones. And I'm again not using the really Quarkus one, so I'm not using beans. I'm just using a singleton class which can create that storage manager for me based on that builder, or can get me the root. The root is here in this case just a list of books. It can give me the root, so if it's not available yet, then it will instantiate it. If it is available, it will give me the already defined one and reads, because I create a storage manager here, it reads then the data from this directory if it contains data. I'm going to show a few of the URLs. I don't have them anymore by hand, so I hope Murphy is not against me today, so that it works fine. I have a few JSONs which are read through this mockup utils class. So it is reading that JSON into into Java objects in a list in this case, just using pure JSON binding, which is also available through Quarkus. So how do we save then data? So initially we don't have any data. So if I would start it now and I'm getting all the books, it will just return me an empty list. So how can I save then something to the database? So let's start by accessing the root. And in this case, I'm going to clear all the books which I might have. So if I have already data, I do a delete of those data. And the next step is that I add all the data here from that JSON. So that are books with authors, a link to an author. And then the next thing what I need to do is save these changes. So these are actually the two statements that I need to do to change my database, the in-memory data. How I store it for the next time my Quarkus program starts. That is by accessing the storage manager and say that it needs to store these books. So I have changed the list of books, namely deleted all items and added new items. So by just putting here the store command, it saves the data in the binary format again. So let's see if I remember it correctly from last week. So first of all, let's try to first it starts correctly. So that's one thing. If I do a curl of localhost 8080 of books, that's the endpoint reading all the books, which yipsy. There is an error. This kind of error says that there is not a required type, means that probably I have changed a few things and there was already data. And you have something like class foo is not equals to class foo because it is loaded by another class loader. You probably have that kind of error also at some point during your career as a developer. Let's see if I put here in the storage manager. Yeah, I have set here the class loader, so that should be okay. See, by default, there is nothing. My database is empty. I can call that get endpoint here. Let me go to that get endpoint again, create where I clear it, add them all, and store it. That just says book successfully created. But if I run them again, then of course they are in memory. And these are all the books. I don't need, just press S2, it will force a restart. Okay, so I'm not used to Quarkus. So this should then completely have restarted my entire application. When I do press S. Okay. Not sure what happens with the memory, because MicroStream does something with memory, but that's the reason why I normally stop it, to make sure that the process dies and that you start again, and that you see, because now I again have these errors which are related to that class loader. So I still might have an issue here with that class loader. Let's see if I started from scratch, if I have still that problem. And I still have an error somewhere. So there is something wrong with the class loader still. So that's something I have to look into. As why this does not work. Let's assume it is just an error from my side, because I don't know Quarkus enough.
Is it maybe because you're storing the books in the database and loading the data root? Shouldn't you store the data root? You get the root, you do some stuff with the root, and then you store the books.
Yep. By default, MicroStream stores only what is changed. So it has internally, it keeps track of what you change and what is not changed. And by default, there is a lazy storer which stops at any point where there is no change anymore. So if I store the root, then it sees that this reference is not changed, because in fact it is a final one. So it actually stops there.
Okay.
So it's not making any change to the books at all. So that's correct. And the only thing that I don't know is why that he thinks that my books that I stored earlier are of a different class than the books that I'm reading the second time. So there is something still with the class loader which is not correct, but I have to find out. An example of that query language then, but you all know the Streams API, I hope. So not going into detail too much here now. So we have from the database root, we have the books, we loop over the books, we filter them to see if the book gets name, starts with the letter A, and we retrieve them as a list in this case. So this is where it say select from book where name starts with an A. That's one example. So that's how you can create queries. Actually, as you see, no use of MicroStream at all. Here, again, this is just purely to have a endpoint, because it creates hard-coded a book, so it is not very useful as in the real world, but just to learn MicroStream. There are again two steps. You need the root which always contains your data. And actually, I'm going to do one step further. I'm going to get to the books and keep here the reference to the books. I have here a new book. So how do I add it to my database? That's by adding book to books. That's the only thing that's needed. Then the rule change what is stored, so that the store here, what is changed, again, the entire list of books, because we added an item to the list, so the list itself is changed. I mentioned already there is a lazy one, so it does not store the entire list. So if you have 1 million items in a book in that list here, which you should not do, having 1 million, there are better ways than you need to use a map where you have already some kind of indexing, which means that you can access your data much faster. But suppose that you have 1 million of items here in that book list. Adding that one book here will not store that 1 million again, but just that single one as an additional, because he finds out that only there is one item changed in that list and the others are still pointing to the same reference there was before. And then means that it is efficient in storing into that storage.
How smart is he with if you remove an element from a list?
The same. You only delete that one element from the list in your storage.
Yeah, but if you have a list of 10 items, you remove the 5th item, then all the items behind it are changed.
Yes.
So is it going to see those as changed? Probably.
No, he actually sees that only that 5th one is removed and will only indicate in the storage that that 5th one is removed and not the other one. So he actually keep that list of references.
Okay, cool.
Update a single book. Suppose that we, okay, books, not books, okay. I think still have a bit of time because this is basics, things which are important. Get me to the root and the books. Find me the book with a certain ISBN number, filter. It's not going to work because it's not a real one, but it does not really matter. I just want to show you one aspect of the golden rule, change what is stored. So book at ISBN, find any. So this is the, if there is that, if we want to update a book with that ISBN number, if we have it, then we can, for instance, make a change or whatever. Going to just do here something like this, not important. But then what is changed? We have changed just the name of that book. So that means that we just need to store the book in this case. So that is all what is needed. This line is all what it is needed to make an update. For update of a, I'm going to put it between quotes, a record, because yeah, we are not using records, but we will probably think a long time still in that in those terms, in those database terms. But sometimes you need to be a bit more clever in the sense that, or you need to be a bit more, you need to do something special if you want to change multiple things. So suppose that all the books that start with an A, we want to give 10% discount. Okay, this example is not made for that kind of thing because we don't have the price, but we have here a list. I'm going to use now a for loop to please everyone. For instance, if you don't like streams, because you can do it also with streams, we do yes, I have a price. Oh, I told it to. I did not have a price. So it is the new price is the old price multiplied by and now I'm behind one of the windows of Zoom, multiplied by 0.9. So we have updated the price of the book. So one thing that you can think is that, yeah, okay, I changed the price. The previous example said that I need to do this. Fine, but there is a problem with this. You have 100 books which starts with an A. After updating 20 of them, whatever, the system crashes or whatever. Which means that those 20 have changed the price, but the other 80 not. So for consistency reasons, we don't have really transactions, or not in that sense. For consistency, this is of course not good. It needs to be all or nothing. At the end of the method, yes, everything needs to be at least stored, and that's sure. Also should also be consistent in memory, but that's another task that you need to do. But this is clearly not good enough. So what can you do? Is that you have that you can create what's called you can access that lazy storer, as I mentioned already, but you can also, as you have seen, you can create an eager storer, which does not stop when it finds a thing that is not changed. But the lazy storer has the advantage that if you access that one, you can also do a store, but it's not changed to the external system. You have to explicitly, yeah, we have called it commit. So then at this moment, only at this line, store it to the external storage. This is creates binary representation in, and that's also important, of heap memory. Why is important? Because if you are using, and that's a general rule, but if you are using MicroStream in Docker containers or any other kind of container, don't put your Java heap to 100% or 95% of the memory that your container has, because then there is also additional, Java itself needs additional memory outside of the heap, but MicroStream is also using additional memory outside of the heap, which means if you put your Java heap too large in a container, that you get that your container will crash, because it will try to read, or will go beyond, the process will try to go beyond the memory limit. So that's a general rule for Java. Don't use 95% or something. I think the optimal value is even 70% or something, that you should not go higher than that. But important, we have not, if it crashes here in the middle, then yeah, no harm is done, because yeah, the process is crashed, so your memory is gone anyway, and your external storage does not contain already the books that were handled at that point. Until what time did you have foreseen, Jago, this block? Was it until 3:30 or was it longer?
You have until the end of this day. I only have 10 minutes for wrap up.
Okay. Let me switch to what is the integration. Maybe I come back to the lazy if we have time. In detail, briefly, I will cover it, but if we have time to show the entire example. We have developed what's called a Quarkus extension, so that that means that we have created some classes that also tap into that build phase, as was mentioned this morning, that build phase which prepares your entire application. So we have created an extension there so that few things are already done at build time for MicroStream, so that you have also additional functionality. That's this is the old name, so it's because it's lacking the Quarkus name, but anyway, it's not available yet. It's only in the snapshot name. That's in the version 8 that we are preparing. And the reason why it's not released yet is because Quarkus requires JDK 11, Quarkus 2, etc. I think for even from 2 itself already, which means that we cannot include it in the code base that we have currently in the MicroStream version 7, because that's still JDK 1.8 based, and we did not have switched to 11 yet. So that means that it can be used on 11, but it's not the build, the source code itself is not moved up to 11. So this build extension, this Quarkus extension will be available in version 8, which we release somewhere beginning of next year, Q1 next year or something. Of course, and I will put a link to the code already. Feel free to just take that code, build it yourself, and then of course you can make use of it. Of course. One thing that we do there is that we use the Quarkus config system, actually the MicroProfile config system within Quarkus, to read all the data. Remember in the config where we set here from the external one, that we can read from an external file like a property file or whatever. Where is it? Here is that property file. We extended in that Quarkus extension. Not this one, it's this one. And we extended to any source that is supported by Quarkus through that MicroProfile config. So you can, for instance, define that storage directory and that channel count here within that application.property file from Quarkus itself, but it can be any kind of file that you've specified. You can have a look what Quarkus provides you there. To make sure that we have never some kind of clashes between names, we expect that each key is prepended with one.microstream. So we have kind of made it a namespace aware. So we have used the package name here so that we make sure that we don't have any clashes with something else. You can also put the integration itself only, or the integration and the core in debug mode, for instance, so that it sees what it does. So that's again a standard Quarkus functionality that you have. You can define the log category of a certain package, and so that's to the level to debug. So that's also something that you can do to find out what's happening. It does several things. One of the things is that, yeah, it reads the configuration properties here, but it also exposes your root and your storage manager itself as a Quarkus bean, as a CDI bean. How does it know what the root is? Because it's not defined here. So here I have a root, and I annotate it with the add storage. It's a method. It's an annotation that we have defined. And during that build phase, we are scanning your code base to find what is the root. If you have defined it, because it is optional, but then you have to define it yourself later on. But the easy thing is that you can define it here, and we turn it in a CDI bean, which means that you can inject the storage manager actually within that root. So no longer the need to have that quirks of getting access to the storage manager within the root. For example, you can just inject it. Transient, why transient? Well, there is no need of having the storage manager itself stored in the external storage. So it's not really part of your database. So just as with normal Java, the transient, all transient properties are ignored and are not serialized. So that's our two main things. We have that the indication of the root. We can inject the root. So if we go to, it is a service that I have created. So if I can, for instance, inject in a service, for instance, in the user service, so then I can access my root there. So I have access to my database by just injecting it wherever I need it. Here already I'm making use of some logs, because you are in a multi-threaded environment and you need to make sure that there is consistency. So that's the reason here why I have that logs. I have read and write logs that I have implemented in an easy way. Have a look at the code. I will put to something to code to this one. I put it in the chat in a moment. This configuration here is most of the time, at least, sufficient to start with. But for instance, to indicate that those additional handlers, those additional microstream handlers, you can do that programmatically by defining beans, CDI beans like this one. They implement a interface of the integration, in this case, the embedded storage foundation customizer that customize that foundation. So the extension at the build phase will find this class and will make sure that it is used at the appropriate time, so that just after the entire storage foundation is created, but before the storage manager is created out of it, you have the possibility, you have the option to adapt that configuration by registering those type handlers, by custom type handlers, whatever. You are free to do what you need to do here. Same for another point of extension. After the storage manager is created, to initialize it. Most of the time it is useful if you want to put some default values in an empty database. We just check that the root within that storage manager, which is already live at that moment, which is active, just created a fraction of a millisecond earlier. to see if there are books, and if not, it's going to add some books as a default. Again, those 13 books which I always reuse in the examples. So that are the ways of using the integration, which we think that it makes sense to make the use of MicroStream even easier. We have this kind of integration for all major frameworks, major runtimes, but also for Quarkus coming up. For the moment, we are a bit limited by the requirement of JDK 11 and JDK 8 between the different systems. Let's start out putting some of the URLs. GitHub. Let's start by the beginning. Here is that basic training, for instance, that config. That is something that you can find here. So config examples, MicroStream. That's this URL. Of course, you can have a look at the entire. Sending it to the. I have to send it to everyone. Config examples, MicroStream. So you can, of course, have a look at all the other things. There is some basic information here, what you can find in which directory. That CRUD one is here, but this CRUD one is using Payara Micro. So I try to adapt it, but as you have seen, I have some issues. So I'll try to fix it tomorrow, and I will put it in a appropriate repository. Then the other one around how you can use Quarkus specific with MicroStream, that's here in the MicroStream Quarkus patterns. So plain is that you're using MicroStream without any integration. So that's a bit the same as I try to do with that CRUD one. So there it works. So I need to compare it to see what I did wrong. And then just with the customizer and initializer without the root bean, and then with the root bean. So that's a storage annotation. So that's that you can all find in here, Quarkus usage patterns. Yeah, if you want to play with it, that's yeah, you can play with that plain one, or you should, and that also works in that basic training. There is under templates, there is also a Quarkus one, which is more or less the same as that plain one. So that's where you can start playing with it. You see, that's just a created from the Quarkus starter, which we also used as the in the prerequisites this morning. But then yeah, there are a few things added like the MicroStream dependencies. It's all documented here also in that templates what more or less is done. So for instance, for the Quarkus one, I started with the classic checksum also. Maybe quickly, if there are no questions, so please interrupt me if there are any questions, because otherwise I can continue. But love to have questions, because then we can tailor this intro to your needs, to your use cases. I don't hear anything for now, so I briefly cover then lazy references. Remember that I said when the storage manager starts, so this is the version without lazy. So when I start here, the storage manager is going to look into that directory here and try to fill up that root object based on that information. In this case, it are photos with an ID and a description and the actual image itself, byte array, which is not bad for the 3 examples. I've added 3 examples in the example program here, so 3 images. Each of them is only a few hundred kilobyte large. So from a performance point of view, that's not dramatic. Let's see if I can get it up and running, because I still have 5 minutes or so more time to do that. Targets, what was the name?
You're missing a minus sign.
Yeah. So I have here an endpoint, which I have already loaded all photos, so that's okay. I have an endpoint which just returns all the photos. I, on purpose, did not return the bytes here, the byte array within this call, because yeah, that makes no sense in returning it, but you will see how I can show you that it is available or not. So we have that controller and it's called photos. So curl localhost, is it still there? Guess lazy, no, how is it called? Data. Photos. So this is now reading all the data and it's not returning any data. So I still have that problem. But I hope I see something in when I take the heap dump, because for those who were there last week, I also had that problem at that time. If you look at the photos array, and we have already lazy photos, so that means that I still have a problem with that example. Where is it? I don't have even the list. So again, I will fail this example. The idea is that I could show you that there was now a byte array with that 2 megabyte of the data, those 3 images already loaded immediately. But the idea is for binary data, especially, or historical data, for instance, keeping all the purchases in that bookshop that we had as last week. So you have a bookshop where you keep the track of all purchases. You probably don't need those from last year or 3 years ago immediately in memory. Only a few requests maybe need that. So that the idea is that you don't have the data immediately, but they are lazy. Lazy loaded means that when storage manager start up, that the actual data is not loaded, only this lazy instance is there. And that takes only 1,000 bytes. And it has a method get, which actually retrieves the actual data loading from disk in this case at that point. So it's kind of a proxy that does not hold the actual data until you explicitly say, get me the data. You can also do a peek to see, yeah, if it's there, I want to have the data, but if it's not there, well, don't bother loading it from the external system. Then you get NULL in one case, or if the data is there, then you get the actual data. And you can also explicitly say clear. Okay, I have used the image data. I don't need it now anymore. So free out the memory. Actually, lazies are implemented on top of weak references of Java. So this clear will make sure that the garbage collector next time, if you do a full scan or when there are memory issues coming up, that those bytes in this case from the image are removed. So clear does not immediately remove it, but it prepares it so that the garbage collector of the JVM is able to remove it from memory. So those are the 3 important ones about lazy, which means that we have now, if we just do a startup, we only have the ID, the description, and this lazy reference, which is capable of loading the image if we explicitly want it. So, for instance, we can explicitly ask for the image data, then we do a get on that lazy, or we can get the lazy itself, but then we just have that that object reference. We don't have the image data itself. We need to do the get on that. Which means that if we are doing a load, if we ask for all the photos, then okay, we only have the metadata, the IDs and the description, not the image itself. But we can explicitly ask for that the data are loaded here. For example, that we explicitly call the get on the on that lazy reference, and then they are loaded. And based on heap dumps, I could show you the difference, but I have to look at my example again. Why it is still not working? Because I thought it was working, but it is apparently not. So that's in brief an introduction to MicroStream. So where we think it is useful, some basic concepts like configuration, reading data through that Streams API, storing data with the store and the storage manager, and the integration there with Quarkus, what it brings for you. And yeah, there are, for those who were not there last week, there are also basic trainings where we have 2 days to go all over these details and even more in more detail. So have a look at the site, at the JAVAPRO.io training site. There you find a list of MicroStream amongst others. And so the next fundamentals training for those that did not follow it is in beginning of November, or an advanced one. There are also It's one day. So if there are no other questions, that was my brief of 1.5 hours or something interjection in that Quarkus training.
All right, I think you were very clear. There are no questions in the chat. So let me wrap up. I will see that everyone gets the slides as well. So I pasted the link to the repository for the microstream also in the slides. So there's only one thing left, and that's a wrap up for today. I was wondering if everybody had a chance to finish the exercises to implement the database and use Liquibase or Flyway. I'm interested to know what you choose. Did you choose Flyway or did you use Liquibase? Or are you cheating and just using Hibernate? Also a chance to see if still everybody is there and awake.
I put everyone into a deep sleep or what? Or?
I don't know. Chat is quite quiet. Then if there is no interaction, I would say just continue on with the exercises and we'll start back tomorrow at 9 o'clock Central Eastern Time. So we don't know what's that in India. Also depends on where you are in India, I believe. And I'll be here until...
So what will you do tomorrow?
Sorry?
What will you gonna do tomorrow?
What we'll do tomorrow, I will just scroll back a bit. And that's for day 2. Day 2 is just a wrap up from where we are. I will show the code that I've built, so we can compare with the things that you guys had made, and maybe finish up today. Then we're building and securing the shop service. Securing is an optional thing. I've just concluded because that's quite annoying to make. I would rather put my time into tracing. That's later on today. But at least you will start to build the shop service, and the shop service will call the product service, the inventory service. A bit of configuration. Then for the afternoon, we'll do health and metrics. I see that configuration also here, so I'm just going to change that. Fault tolerance, build a native image, and the wrap up of the course. And I'm going to introduce tracing. That's going to be here. So that's for tomorrow.
Okay then.
And I'll be here until 6 or until